Okay, this video is meant for my geometry students. We have a test coming up, or a quiz, over sections 10.1 through 10.5. Here is your quiz review. Okay, so number one, here, we need to find the value of h. And if you look, this is a parallelogram. And again, every parallelogram has two pairs of bases and heights. So if we look at this first, in this picture, this h that we have to find pairs with the point 5. So I'm going to circle those in blue. And then the other pair, the point 3, because it's perpendicular to the bottom here, pairs with the point 4. There are your base pairs, base and height pairs. So if I want to find the area of this parallelogram, I can't use h and point 5 because I don't know h. I can use point 3 and point 4. So area is base times height. Area is base 0.4 times height 0.3. You go to your handy-dandy calculator. 0.4 times 0.3 is 0.12. And that's units squared. But that's not what they want. They want the height. So now we can use that area and the base they have to find the corresponding height. Area is 0.12. The base they give me is 5.5, and the height is h. And we divide both sides by 0.5 to find the height. And when you divide by 0.5, you get a height of 0.24 units. So remember, every parallelogram has two heights and two bases. Okay, next problem here, coordinate plane problem. We want to find the area of this polygon, sorry about that, with the vertices given. So I have a coordinate plane here. These are all positive, so it should fit in the first quadrant. Let's see if this will fit. E is at 1, 1. F is at 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's F. G is at 11, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5. And H is at 8, 1. 1, 2, 3, 4, 5, 6, 7, 8, 1. Oh, sorry, I counted H too far. I apologize. Undo. I counted H too far. I counted over 9. It's only 8. 1, 2, sorry. 1, 2, 3, 4, 5, 6, 7, 8. 8, 1 right here. And there's the picture. And this is a parallelogram. So it is a parallelogram. So the area of a parallelogram is base times height. The base, if I count, and I'll go back to my red, EH, 1, 2, 3, 4, 5, 6, 7. There's the base, 7 units. The height is just from the bottom base to the top base. So if I go from F down 1, so I could draw this height right here. 1, 2, 3, 4. The height is 4. And you can do that anywhere. So now I know that the base is 7, the height is 4, area is 28, and that's units squared. There's a coordinate geometry problem. Okay, next, area problem. Use Huron's formula to find the area of the triangle. So remember Huron's formula, and we really didn't talk about it much, so I understand. I'm going to give it to you. Area is the square root of S times S minus A, S minus B, S minus C. That's all inside the square root. Where S is equal to what's called the semi-perimeter. It's the 3 sides of the triangle divided by 2. So again, pretend you're given a triangle. I'll draw a picture here. ABC. A, B, and C. A is 8 inches. B is 9 inches. And C is 10 inches. So you're given this triangle and they want to find the area. So it's not a right triangle. It's side, side, side. How do you do it? Well, you use Huron's formula. First, you have to find the semi-perimeter S. So S is equal to A plus B plus C, all divided by 2. Add the top first. You could probably do it in your head. 8 plus 9 plus 10 is 27, and then divide that by 2. And you get 13.5. That's S. So then when I fill in my formula, I like to do the subtractions. I don't like to fill all that in. So I'm going to do 13.5 minus A, and A is 8. 5.5. 13.5 minus B, and B is 9. 4.5. 13.5 minus C, and C is 10. 3.5. And that is what I'm going to type. Oh, it's terrible. That's what I'm going to type in my calculator to get my area. So I'll do the square root of 13.5 times 5.5 times 4.5 times 3.5. And I'll close my parenthesis. And I get rounded to one decimal place, 34.2. And that is going to be inches squared. So again, Huron's formula, I'll have it on the board, just got to be able to plug in the numbers. Make sure you do the note card though. Okay, here's the fourth problem. We're going to find the area of the rhombus here. And so they give us 4 meters, which is this part of the diagonal, and they give us 60-degree angle right there. Okay, first thing, area of a rhombus. 1/2, diagonal 1, diagonal 2. What a rhombus does when the diagonals are crossing, when they intersect, form right angles, and they bisect each other. So if this is 4, so is that, and this right here is 8 meters, and that's one diagonal. Now, we need to find a second diagonal, and to do that, we're going to pull out this right triangle. See this right triangle right here? I'm going to pull it right down here. 60 degrees, right angle, this is 4 meters. This is a 30-degree angle. And this is a 30, 60, 90 triangle. I need to find this, call it X. I need to find that, so call it X. So I can do that using the 30, 60, 90 principles. Now, in a 30, 60, 90 triangle, a hypotenuse is 2s, the shorter leg is s, the longer leg is s radical 3. I want to find x. X is s radical 3. Well, if s is 4, then x is just 4 radical 3 meters. And there's your x. There is this length right here. Okay? So x is 4 radical 3. So this right here. So that means this is also 4 radical 3 meters. So they're both 4 radical 3 meters. Add those together. 4 radical 3 and 4 radical 3 is 8 radical 3 meters. And there's the diagonal. And we plug it in. Area equals 1/2. The first diagonal was 8. The second one is 8 radical 3. When you use your calculator, you will get 55.4, and that's meters. 55.4, and that's meters squared. So remember your Pythagorean theorem. Remember your 30, 60, 90, 45, 45, 90 triangles. Okay? All right. Okay, fifth problem here works with the section 10.4 on the similar figure. So we have the areas of two parallelograms given to us. We need to find the scale factor and the perimeters, the ratio of the perimeters. So first, the areas. Okay? Well, area ratio is 18 to 32. Divide each of them by 2. 9/16. That's the simplified ratio of the areas. So now to find the scale factor, we simply take each of those numbers and find the square root. And those are both simple, or they're both perfect squares, so we get 3/4. And the ratio of the perimeters is equal to the ratio of the scale factor. And there we go. So very simple, simple section there. Shouldn't be too much trouble. Okay, 2 more problems left. Find the area of the regular polygon round to the nearest tenth. And we're going to work with a pentagon of radius 3 feet. Okay, so again, we need to remember that first, a pentagon has 5 sides. The area formula that we're going to end up using is 1/2 a times n times s. The a is the apothem. They don't give it to us. N is the number of sides, 5. S is the side length. They don't give it to us. They give us the radius. So you must draw a picture. Okay, pentagon, house. There's my center. There's my triangle. I'll draw down my apothem. Okay? And I'll label my radius as 3 feet. Sorry, 3 feet. Okay, so first thing I need is the central angle. Alright, I need this angle all the way across here. Well, how do I get that? Well, I take 360, and I divide it by the number of sides of the number of triangles, which is 5. And that's 72 degrees. So that's the angle all the way across. Okay? One more thing, let's label the side length S, because that's what we need to find as well. But in reality, I just want the portion right here. What that is, that angle. And to get that angle, we take 72 and divide by 2. And that's 36 degrees. That's the angle I'm looking for. So now to find the apothem and the side length, I'm going to take that triangle and I'll bring it right over here. And this one I'll make a little bit bigger. I made that picture a little small. The angle right here is 36 degrees. This is the apothem A. This is the right angle. This is the radius, 3 feet. And now, we don't have the side length on this picture, but we do have half of the side length, so I'll call it x. And remember that once you find x, you have to double it to get the side length. So now I need to find a and x. This is a 36-degree angle. We use trig. From this 36-degree angle, x is the opposite, 3 feet is the hypotenuse, a is the adjacent. The apothem is the adjacent. First, let's find the apothem by using adjacent and hypotenuse, that is cosine. Cosine of 36 equals adjacent over hypotenuse. And times both sides by 3. And you will get your apothem. I would suggest you leave it to a couple decimals. 3 cosine of 36 is 2.427. And that's in feet. Now I'll do a similar thing to find x, except x is the opposite side. I want to use the hypotenuse. That's sine. Sine of 36 equals the opposite x over the hypotenuse 3. And again, multiply both sides by 3. 3 sine of 36 degrees. And I get 1.763. Okay? But I do want double that, because I want the side length. Remember, s is what I really want, is equal to 2x. So just test times 2, double that, and I get 3.527. 3.527. 3.526, it doesn't matter. And that's feet. And that's my side length s. So here are my numbers. A, 2.427. S, 3.527. And N, 5 sides. Plug it in. Area equals 1/2 times A, 2.427 times N, 5 times S, 3.527. And we plug that in our calculator and we get an answer of 24.1, and that is going to be feet squared. Area equals 21.4. 21.4, and that's feet squared. Okay. Remember, there's also problems where I give you the side length and you only have to find the apothem. So understand, but it's still a trig unless it's a special right triangle. So be aware of these problems. Make sure you practice them and get good. Okay, last problem here says find the area of the triangle, round to the nearest tenth. And you notice this situation is side angle side. We have a formula for that. Now, before I do the formula, I'll label my picture A, B, C, lowercase a, lowercase b, lowercase c. So the formula I know, area equals 1/2 the two sides BC sine of angle A, the angle in between. And I'll just fill it in. Area equals 1/2, B is 104, C is 226, sine of A is 40 degrees. And again, just type it in the handy dandy calculator. And I get something big, like 7554, and it's actually 0.0. And that's meters squared. So just be able to make sure you can plug the numbers in the formula. And this will not be given to you, so make sure you remember this formula. Okay. Alright, so hopefully this review helps, and you feel prepared coming into the test or the quiz on Tuesday or Wednesday. Alright, enjoy your spring break, and thanks for watching. We'll see you next time.